Okay, good evening, everyone. This is Michele Calvano. Flavia Camagni is present online. First of all, I would like to thank the symposium organizer for selecting our contribution for the oral presentation. This work explores the use of a particular type of artificial intelligence for analyzing and automating geometric procedures in a CAD environment. The study's main goal is to apply the potential of ChatGPT to solve specific descriptive geometry problems when drawing within a NURBS modeler. On the slide, you see the organization of the communication. It is divided into 6 parts. In the first part, we frame the problem. In the second part, we explain the graphical algorithm behind the digitization process. In part 3, the solution is automated using the visual programming language. The main part is 4, showing how AI can mediate between the geometric and the programming processes. Finally, some concluding remarks. Generally, intersection of NURBS surface generate interpolation curves whose complexity, degree and number of control points, is a function of the entities participating at the intersection. This also applies to the intersection of plane and cone. The result is a closed third-degree curve with a sequence of control points useful for bridging the entity that has the shape of an ellipse, but not characterizing geometry like axis and foci. In this slide, on the left, we see the result of the intersection of a plane and cone in the NURBS environment. On the right, the topology of an ellipse drawn directly in the same software. What we see on the right is a closed second-degree curve with non-uniform nodes and a cage of control point closely related to the direction of the axis. The secondary aim of this work is to expose the procedures required to transform the left curve into the right curve, also using artificial intelligence. The graphical solution to do this is known to all geometry experts. However, we summarize it in this discussion since it is the algorithmic basis of the programming process in both visual language and textual language. What you see in the slide is the curve resulting from the intersection of the plane and the cone, which is a third-degree entity with many control points. The geometric process for identifying axis consists of A. Construct 2 pairs of parallel chords belonging to the plane of the NURBS curve and intersect it. B. Draw 2 lines passing through the midpoint of the chords. C. Intersect the 2 lines to locate the centroid of the NURBS curve. D. Construct a circle belonging to the plane of the NURBS curve with the center coinciding with the previous point. E. Intersect the circle with the NURBS curve. F. Use intersection point as a vertices of a rectangle. G. Draw 2 axes passing through the center of NURBS curve, parallel respectively to the long and short side of the rectangle. H. Construct an ellipse starting from the identified axis. With the axis just identified, it is possible to draw the ellipse in direct mode, which will have a topology typical of an ellipse in a NURBS environment. The accuracy of the geometric process allows the intersection of only one configuration of plane and cone to be resolved. Moving one of the 2 entities will require repeating the entire graphical process on the new intersection curve. The same procedure, written in visual programming language, returns a continuous solution applicable to different configurations of the plane and cone. The result is a dynamic model for which the configuration type that returns the elliptical section is always solved. Let's go into the details of the solution described by means of textual programming. Again, this will produce a result applicable to the type of configuration investigated so far, returning a continuous output. Rhinoceros lets you combine visual programming language with other language like C#, Visual Basic, and Python. You can use Python to create a grasshopper component that generates an ellipse and a related shape from an intersection curve. While programming is becoming more common, it's not a typical skill for geometry scholars. Artificial intelligence can learn to program. There are many online apps that can help, such as ChatGPT, Gemini, Jasper, Cookie, Replica, and others. This presentation shows how to use ChatGPT to translate between geometric language and programming language. Descriptive geometry is a language for representing graphic algorithms. Python is a similar language for describing algorithms that can be used to create tools or digital components. The mediation takes place through the description in natural language of geometric action in AI chatbot that responds with a programming code solving the problem. Our past experiments prove that instruction for automating this process must be given in a specific way. This is because AI must understand the context in which it operates. Let's read the instruction on the slide. Creates a Python component of grasshopper to transform the NURBS curve resulting from the intersection of cone and plane into an ellipse. The input is the curve. The output is the ellipse, minor axis, major axis, and foci. The chatbot doesn't understand this instruction. It can't reduce a complex problem into smaller and easier problems. For this type of activity, human intelligence helps artificial intelligence. How you understand the problem can break it down into small tasks that AI can do. This scheme is the result of human analysis that make the problem easier to understand by divide the problem in small additive tasks, define the output of every task, describe the task in natural language for AI chatbot, generate the Python code, review and debug the code, optimize the final code by defining input and output. At the end, you get a Python code that can be added to a grasshopper component. In this slide, instructions written in natural language that follow the rule are in black. Instructions that don't follow the rule but fix the problem caused by AI misunderstanding are in cyan. Final instructions to make the code more efficient and readable for grasshopper component are in gray. Let's go into operational detail. On the left, we see one of the first instructions written in the AI chatbot. On the right, the response. What we get are the lines of code that respond to the request. The structure of the code is extremely neat and enriched with notes that allow checking, reviewing, and learning the code. This experience led to several reflections. Some were about the process, while others were about the new components' computational efficiency. You can see how the new component makes code faster by comparing code with and without it. Less components means less time and less power needed for computation. This new component can also affect other applications involving conic sections. For example, Dandelion sphere need to be identified using the conic section foci, as shown in this image from Riccardo Migliari's book. We can now appreciate a continuous resolution of the exercise by looking at cases under the elliptical section model. This presentation is not a way of solving the specific problem, but a method for digitizing geometric procedures through the mediation of an AI tool. With this video, I have concluded my presentation. Thank you for your attention.